Hello guys, welcome to my next video for M.Sc Mathematics. So in this video, I will be giving you some very important question of abstract algebra that often come in university examination. Okay, so let us see what is the question. Let G be a group with subgroups H and K such that H and K are normal in G, and H intersection K equal to the identity element E, the set of the identity element E. Then HK is the internal direct product of H and K. Okay, HK equivalent to H Cartesian product K. Okay, since HK are normal in G, so HK is a subgroup of G. Let H belongs to H. Here small h is the element of the set H. Okay, and here small h is the element of this set H, and or you can say group H, and K belongs to K. Small k is also an element of group K. Okay, since H is a normal group, okay, H is normal to G. This means this sign means normal subgroup. Okay, this means normal subgroup. So as H is a normal subgroup of G, that means, what does that means? That means if we have element K, H, and then K inverse, that will be belong to H. Okay, K inverse H will be belong to H. Why H inverse K? Because K inverse will return identity element, right? That is why K inverse belongs to H. So that K inverse H inverse belongs to H. Also, K is a normal subgroup of G. So what will happen? We can write H inverse also will be belongs to K, because H is an inverse identity element. So that will give us what K. So that means that H inverse K will belong to K also. Okay, so that can be written like this. We can take K outside, then H K inverse H inverse. Okay, we can take K outside, then this that really belongs to K. Okay, now we have, it is given that H intersection K is identity element. Okay, so what does it mean? It means if we write K inverse H inverse equal to E, then we can separate KH and HK inverse equal to E. That means HK equal to KH, so that every element of H commutes with every element of K. Now each element of HK can be written uniquely as a product of HK. Okay, for H belongs to H and K belongs to K. Let, if possible, HK equal to H1 K1 inverse. That implies H1 inverse H equal to K1 K inverse. Okay, now H1 inverse H belongs to H, and K1 K inverse belongs to K, so that H1 inverse H equal to K1 K inverse, that belongs to intersection of H and K, but H intersection of HK is identity element. So we can write that H1 inverse H equal to identity element, or H1 equal to H, and K1 K inverse equal to identity element. That means K equal to K1. Hence HK is the internal direct product of H and K. Now define the map. Phi, if we define map as phi, then phi belongs to HK, and which tends to H Cartesian product of K by phi HK equal to H, and within the closed interval K. Phi HK, this is the map, this is called mapping. Phi HK H1 K, where H1 belongs to H and K belongs to K. Phi is well defined, and phi is a bijection, since the representation of each element of HK as a product of the form HK is unique. Also for H1, H2 belongs to H and K1 belongs to K, we have phi, that the mapping H1 K1 H2 K2, right? H1 K1 H2 K2. What does that mean? That will be equal to phi H1 H2 K K2, since every element of H commutes with every element of K. Okay, that can be written as phi H1 H2 K1 K2, or H2 H1 comma K2 K1, or H1 K1 H2K2, and that will give us phi H1K1 and phi H2K2. Hence phi is an isomorphism, and that means HK equivalent to KH, right? HK equivalent to H cross product H, you can, sorry, cross product not it is, this is called Cartesian product. So HK, the product of HK will be the equivalent of product Cartesian product of HK. So what was the question? What was the question? The question was, we have to prove that HK is the internal direct product of H and K, and HK, product of HK, will be the equivalent to the product of Cartesian product of H and K. So that is proved. Thank you for watching. Please subscribe my channel to know that this kind of questions which often come in university examination. Thank you for watching. Bye.